In a modern retail store, the shelves are a testament to global efficiency, showing thousands of products sourced from every corner of the planet, all readily available for purchase. The lighting is bright, the aisles are clean, and the impression is one of seamless abundance. Shoppers can find everything, from exotic fruits grown thousands of miles away to intricate electronics assembled across multiple continents. It operates so smoothly that most of us rarely consider the complex journey each item has taken to reach our hands. Just a few miles away from this retail paradise, however, a different story is unfolding. In a factory that produces components for consumer goods, the production line has ground to a halt. Managers are on the phone, trying to locate a single crucial part that has failed to arrive on schedule. The warehouse, which should be bustling with activity, is quiet, creating a ripple effect of disruption that seems to contradict the very efficiency the system is built upon. This strange situation presents a fundamental contradiction. How can a store be filled with finished goods while the factories that make them are reporting critical shortages? The appearance of success on the retail floor masks a hidden fragility upstream in the production process. Instead, it lies within the design of the global supply chain itself. The system is engineered to be lean, fast, and cost-effective. These are the qualities that deliver low prices and vast selection to consumers. Yet, these same principles might be the source of its inherent vulnerability. At its most basic level, a supply chain is the network of organizations, people, activities, information, and resources involved in moving a product from its initial source to the final customer. It is the complete journey of an item, from raw material to finished good. This journey begins with suppliers, then moved to manufacturers, then managed by logistics providers, and finally, retailers. Beyond the physical movement of goods, two other critical flows define the supply chain: information and money. Information flows in both directions. Customers' purchasing decisions create demand data that travels back up the chain, while information about shipping status flows down the chain to retailers and customers. Simultaneously, money flows in the opposite direction of the goods. Customers pay retailers, who then pay manufacturers, who in turn pay their suppliers. Finally, regulatory bodies are silent but powerful participants. These are government agencies and international organizations that set the rules for trade, safety, and labor standards. Together, all these participants form an interconnected ecosystem. The actions of one member can have immediate and far-reaching effects on all the others, creating a dynamic and constantly evolving system that powers the global economy. The global supply chain is engineered to achieve three main goals: keeping costs low, ensuring fast delivery, and maintaining high product availability. While these objectives often work together, they can also be in conflict. The cheapest shipping option is rarely the fastest. The constant effort to balance these competing priorities is a central challenge for supply chain managers. When supply chains break, the most visible causes are often acts of nature or human actions. A hurricane can shut down a port. A labor strike can halt a factory. However, blaming these events alone provides an incomplete picture. They act as a stress test, revealing pre-existing weaknesses. They are triggers, not root causes, exposing a deeper fragility built into the system's design. Other disruptions originate from within the supply chain itself. Forecasting errors are a significant challenge. At each step upstream, uncertainty amplifies. This is the bullwhip effect. Small, consumer changes cause huge swings for manufacturers. Just-in-time manufacturing, or JIT, aims to minimize waste by holding minimal inventory. Parts arrive exactly when needed, but this efficiency comes at the cost of buffers. Inventory is a shock absorber. With strict JIT, a small delay can halt an entire production line. To understand why the system is so fragile, we must look at the incentives that guide every company. Corporate performance is measured by metrics like quarterly profits and inventory turnover. Managers are rewarded for trimming expenses. This focus on cost-cutting directly discourages building resilience. Keeping extra inventory, or a backup factory, looks like inefficiency on a balance sheet. The pursuit of local optimization can unintentionally lead to global fragility. Another hidden driver is the presence of long delays, or lead times. In a global supply chain, it can take months for raw materials to become a finished product. Because it takes so long to get goods, companies must make decisions far in advance based on forecasts that are likely to be wrong. Delays also worsen the bullwhip effect. If a retailer fears running out of stock during the long wait, they may increase their orders, creating phantom demand that sends a distorted signal up the supply chain. The modern economy is also built on specialization. For many critical components like advanced microchips, a few highly specialized foundries produce them for the entire world. While incredibly efficient, this creates extreme fragility. The world can become dependent on a single factory. If that factory shuts down, the global supply of that component can instantly disappear, causing cascading shortages across multiple industries. A final hidden driver is how risk is transferred. A large retailer might require its suppliers to hold stock on their behalf. The retailer avoids the cost of inventory, but it is transferring both the cost and the risk of stockouts onto its partners. The total amount of risk in the system does not decrease, it simply concentrates in the weakest points of the chain, often with smaller suppliers who have less ability to absorb shocks. The consequences of supply chain fragility extend far beyond individual companies. When disruptions occur, one of the most immediate system-wide effects is on prices. Employment is also directly impacted, creating a drag on economic growth. Moreover, the system's design has turned critical infrastructure into single points of failure on a massive scale. Major container ports, vital shipping canals, and key highway interchanges were not designed with significant redundancy in mind. The same fragility exists in digital infrastructure. A cyber attack on a major shipping line's IT system can bring the physical movement of goods to a standstill. Their consolidation means a single digital failure can have consequences as severe as the physical closure of a port. This makes the entire system vulnerable to a new and growing category of non-physical threats. The effects of a single disruption can quickly cascade across the globe. A shortage that begins in one country rapidly spreads to others through trade links. This creates a shared vulnerability where a problem anywhere can quickly become a problem everywhere. These disruptions also trigger significant policy responses from governments. A common response is to offer subsidies to encourage domestic production. Another set of policy reactions involves the use of trade restrictions. If every country hoards its own resources, the international market can break down completely. These beggar-thy-neighbor policies can set off a chain reaction of retaliatory measures, further fragmenting the global trading system. Our journey through the global supply chain has revealed a fundamental insight. The system is not fragile because it sometimes fails. It is fragile because of the very principles that make it work so well. The empty shelves and halted factory lines are not signs of a broken system, but rather the logical consequence of a system designed for a single purpose: maximum efficiency. The system's greatest strengths are also the source of its deepest vulnerabilities. This means that fragility is an emergent property of the system itself. It arises from the rational, independent decisions of countless actors, all responding to the same set of powerful incentives. Recognizing this allows us to reframe the problem. It involves diversifying suppliers, strategically building buffers of critical inventory, and improving information flows with shared data platforms. These potential solutions, however, bring us to a difficult and unresolved tension. This abundance was made possible by the very efficiency that also creates fragility. Building a more resilient system will inevitably come at a cost. A more resilient supply chain is almost certain to be a more expensive one. This presents society with a fundamental trade-off. Are we willing to pay higher prices for goods in exchange for a more stable and reliable supply? This creates a difficult collective action problem. The benefits of resilience are shared by everyone, but the costs are borne by the individual companies or consumers who make the more expensive choice. These questions pit the immediate, tangible benefit of low prices against the abstract, probabilistic benefit of avoiding a future crisis. There is no perfect solution, only a complex set of choices between cost, convenience, and security. The design of the next generation of supply chains will depend on the answers we find to these difficult questions. You've been watching System Atlas, exploring how the world's systems really work. Share your comments below. See you in our next episode.